We're going to start off with a very easy proof, and then we're going to look at some applications of it, and then we're going to look at some limitations of it as well, which you may have seen the sine rule before, but I haven't shown you this ambiguous case that we need to consider. So, we remember when we're calculating area of a triangle, we can just write as half AB sine theta, okay? But if I'm going to draw this triangle here, where we've got, again, angle A and side A are opposite one another, angle C and side C, angle B and side B, they're all opposite one another. So if we're going to make a statement about the area from this triangle, okay, we could calculate the area using these values, half times B times C times sine A, okay, that's my first statement. Or you could do half times A times C of sine B, or if you have this angle and these two lengths, half times A times B times sine of C. So because they will all generate the area, therefore they are all equal to one another. Okay? So we've got that, we've got this equation here. And then all we're going to do is we're going to divide all of them. We can do anything because they're related, as long as we do it to all three of them. If we divide all of them by half ABC, and half ABC. So then, like what's common at the top and the bottom, we can cancel our halves. Here we're going to cancel B and C. Okay, here we can cancel half A and C, and here we're going to cancel half A and B. And let's write what we're left with. What we're left with is we've got sine A on A equals sine B on B equals sine C on C. And this is the sine rule. And so this is a fairly easy proof, and we've already proved this as well. We proved this last lesson. So we've got sine A on A, sine B on B, and then that means the inverse of that is true, the reciprocal. If we form, because these fractions are equal to one another, therefore their reciprocals are equal to one another. So another way we can represent that is A on sine A is B on sine B is C on sine C. So last lesson we learned the cosine rule, and we said we use the cosine rule for problems that have three sides and one angle. We use the sine rule for problems involving two sides and two angles. If we're finding an unknown angle, we're going to use this representation, and if we're finding an unknown side, we're going to use this representation. Okay? And really, we only need to consider like this. All right? We only need to consider those two. Okay, so let's move on to the first example. Here we're going to find an unknown side. So I always say, make your unknowns A. So if our unknown side is A, that means our angle here is A, and this angle is going to be B, and this is B. So the sine rule says sine of A on A is equal to sine of B on B. Let's plug in the information we've been given. A corresponds, it won't matter so much, but I did say if we're finding a side, we should use this one. Okay, it's just going to require less algebra involved. So we should express it as A on sine A equals B on sine B. That's what we should do when we're finding an unknown side. Okay, so A corresponds with X, and angle A is 80 degrees. So we've got X on sine 80 equals 7 on sine 60. We're going to isolate X by itself by multiplying both sides by sine 80. And then we will calculate that. We need to make sure our angle is in degrees. That's 7.960, which is 7.96 units. We're not given an explicit unit there. Okay. So in the next one, we're asked to find an angle, and I've said whatever the unknown is, make that A. Here we have an unknown angle, so that's going to be capital A. Here's our lowercase a. This can be angle B and side B. And so I'll make the statement, because we're finding an angle, we're going to use the form with sine at the top. So sine of A on A is sine of B on B. So that'll be sine of m degrees is what we're trying to find. We're trying to find this m. On top of 8 is sine of 75 on top of 10. Okay, we'll isolate m. We'll isolate sine of m first. Okay, by moving the 8 on the other side. But remember, we're trying to find m. We're not trying to find sine of m. We're trying to find m, which means we need to do inverse sine of whatever this. When we've evaluated that, we do an inverse sine of it. You can do it in one big step, you know, inverse sine of this whole thing in brackets. I'll crunch it now. I think it was 50.6 or something. .60, which is 50.6 degrees. Okay, now that might look like, yes, we've solved the answer, but this is where we're going to take it a little bit further. In all circumstances where we're finding unknown angles, we're going to find two unknown angles, and I'll tell you why in a moment. The other angle is going to be 180, take away the angle we found. So what's that? 130, 129. Okay, so whatever the angle is we found, first angle was M1, that's the first possible value. Second possible value is M2, 180, take the angle. Here's why. Here's why we need to consider two possible angles. Consider this information that we're given. We have angle A is 25 degrees and side A is 5 meters. Angle B, we're trying to find it. We're trying to find this unknown angle, and we've got side B is 10 meters. Okay, so if you were to try and draw this triangle, all right, we could draw it like this. Okay, so we've got angle A and side A, angle B and side B. Or we could draw it like this. Okay, and so you can see, because of the information we're given, there's a bit of ambiguity around which angle it wants you to solve. And so this is what we call an ambiguous case. And so angle, we're going to calculate it in one circumstance, and then the other possible angle would just be 180, take the one we're given. Okay, so whenever we're calculating only an angle, not a side, whenever we're calculating an angle, we need to consider there could be two possible solutions. All right, so 6C.1, you're finding unknown sides. 6C.2, you're finding unknown angles. And that'll be what we dedicate today's lesson to. Before we begin, I'll just spin this around, give a bit of a summary here. Just sent an email about this, maybe some of you have opened it already. So this is what's happening in the next few weeks as we near the end of the semester. This is where we are today, Tuesday. We're doing 6C, the sine rule. We've got 6D tomorrow, which is problem solving. There's not a whole lot to learn there. It's just applying some of the sine and cosine rule stuff we've learned. And that'll be the last thing we need to do. Then we have student-free day. Your folio is due on Friday. Okay, if that's an issue, let me know soon. Week 8, we do some revision on Tuesday and Wednesday for the test on Friday. Now that means our test will go over recess. So again, we'll probably start at 10:30, give you a few minutes at the start to have something to buy to eat, and we'll finish early as well. Then we come to week 9, where we're just dedicating the time to exam revision. So on Tuesday, we'll revise functions and relations. On Wednesday, we'll revise polynomials. Friday will be a bit of a DIY lesson. Here's some information about the exam. It is formative. It goes for 2 hours. You can bring 2 single-sided sheets of handwritten notes, or 1 double, if you want to just make it 1. Sorry, I was just trolling people. So 1250 to 250, and it is formative. We will provide you with a unit circle in both the test coming up and the exam coming up. Okay?